Okay, so question 10 here. T1, which I'm saying is the tension in rope 1. I know, mind-blowing stuff right there. But T1 ends up being about 6,395 newtons. Obviously, you could round that off about 6,400. And T2 ends up being about 4,375. So if you got those, feel free to skip the rest of this video because you are done with this third homework. Right? If you need to see at least the setup for this, I will help you set it up again. Okay, so the biggest thing here, they give me the mass, which means I can find my force due to gravity by simply taking that times 9.8. So 1,000 times 9.8, maybe the easiest calculation of the day, is 9,800 pulling downward, right? Be careful in that T1 plus T2 does not equal 9,800, right? Notice these two numbers here do not add up to be 9,800. However, when I break each of these ropes into components, right, which I have to do for all of these static problems, all of these problems where it's not moving, as I break it up into components, the two vertical components, so T2y and T1y, if you will, those two components have to add up to be equal to 9,800, right? So that then leads me to my first of the two equations that I'm going to need, right? So again, T1y plus T2y, the two vertical components, have to collectively add up to 9,800. Well, I don't just want to leave them this way. I want to represent them in terms of the actual hypotenuse, right? So using the angle of 20, the vertical part would actually be the cosine part, right? Because if this is 20 here as well. Okay, so T1 times sine of 20, excuse me, cosine of 20, I messed up right there. T1 times cosine of 20 plus T2 times cosine of 30 equals 9,800. Now the other common mistake that you do have to make sure you avoid here, these two ropes do not evenly divide the 9,800. So unfortunately you can't just make this a triangle and say, well, this rope's going to support 4,900 because it's going to support half of it. We can't do that unless we know for sure those two angles are equal, and obviously in this case we know that those two angles are not equal. Right, so here's my first equation, here's my first relationship, got it set up, no big deal. Right? The problem is I get stuck because I have two variables. So that's where the horizontal pieces come into play. I know that because the beam is not swinging from side to side, that those two horizontal forces have to be equal and opposite as well. So T1 sine of 20 needs to be equal and opposite to T2 sine of 30. So this gives me then a second equation, which I can solve for. Right? So just dividing both sides by sine of 20 to get T1 by itself, and it doesn't matter which one we choose to get by itself. But then I can substitute this entire mess in over here, and at this point it is just algebra. Right? So I'm going to trust that most of us can do that. Right? Just plugging this in, T2 sine of 30 over sine of 20, but I still have the cosine of 20 hanging around, and then I still have plus the rest of this equation, right? So plus T2 cosine of 30, and then equals 9,800. And again, just cleaning this up, making sure we follow our numerical values out. I never round these off if I can avoid it, right? So take these out to as many places as possible, or don't round your answer until you have to, right? But when you solve for T2, that's where I got, again, my 4,375. So then to solve for T1, I do not just take 9,800 minus this, right? Because again, just the vertical components supported it, so I don't just subtract them. All I have to do though is substitute that T2 back into this equation, which I've conveniently solved for T1. And so that's where I get my T1 value, right? That's where I get my T1 of 6,395. Anyway, hopefully this came back pretty quickly, right? We've seen these type of questions before going back to Physics 1, but if it did not, if you did need some further assistance, here it is. You definitely need to be comfortable with this. I do expect you to know how to do this for both this problem and much more complex problems on top of this. So make sure if you do have any questions, you come find me. Do not just let this sit if you're not sure.